Local Edition. Brad Pomerance here on the Central Coast. We are joined by Jean-Pierre Wolff. He is the Vice President of the Coastal San Luis Resource Conservation District, but also the Chair of the Central Coast Regional Water Quality Control Board. I thank you, sir, for joining us.
Thank you.
Dealing with issues relating to water and the drought. And I'd love to speak with you about a word that's increasingly used in our vernacular, and that is desalination. Let's start from the beginning. What is desalination, sir?
Desalination basically is associated with taking ocean water and then you reverse osmosis that water to bring it to drinking water quality standard.
And when you say reverse osmosis, meaning you are pulling certain elements out of that water.
Right.
And those elements are, I presume, salt.
Salt, because seawater has a high salt content, so usually the rejection rate, meaning if you take, for example, 100 gallons of seawater, you can produce approximately 55 gallons of drinking water.
Okay.
The rest is rejection because it becomes basically a brine.
And what does that mean?
The brine has a lot of constituents, solids, and of course salt being one of the primary constituents.
And what happens with that, quote, rejected water?
Well, that's one of the environmental challenges, is that in past years, and when I say past year, a decade ago, you would basically discharge that brine back in the ocean, but it has been realized that you basically develop a plume in the bottom of the ocean floor, and that plume of brine is toxic to small aquatic life, larva stage, for example, or egg stage. So the new requirements that have been developed by the State Water Board is that this rejection water has to be diluted and also diffused in to prevent these plumes from developing.
And so are we putting the treated brine back into the ocean?
Correct. But it has to be treated in a fashion that it reduces the toxic impact of having these high salt content delivered back in the ocean.
So given that we need to treat the water, which presumably is energy intensive, it's through the reversed osmosis.
Correct.
So we have treatment coming in, and then we have to treat it going out. Is desalination a wise part of an expanded portfolio?
It is viewed to be a part of a solution. It's expensive water for sure, but when you do have significant droughts, it helps provide a little bit of a balance in the overall portfolio. As an example, the biggest desalinization plant in North America just opened in San Diego
area.
Right,
the Carlsbad plant. Let's talk about it. It's the biggest project in the Western Hemisphere. Almost $1 billion to put online. Took 15 years to complete. It's considered in a lot of ways the gold standard. We see that San Diego County will be getting 50 million gallons daily, or about 7% of the need for their 3 million residents, but it's a bit expensive. Normally, the MWD water would cost about, let's say, $925 an acre foot. Recycled water, about $1,200 an acre foot. Desal, $2,200 an acre foot, which causes San Diego customers' bills to rise about $5 to $7 a month.
Correct. You have done your homework,
I have done my homework. That's rare, but I try. So, is it worth it?
Well, when you run out of water, then
it's worth it.
It's worth it. And if we look at some other countries, if you take the Middle East, for example, or you take countries such as Israel, there'll be
Israel, as I understand it, desal is essentially their main water source.
That's correct. That's why I bring it up.
They can't survive without it. And then I was reading that in Saudi Arabia, they're looking to create a desal plant, but as a way to minimize, well, I don't know if this is their reason, but they're looking to energize it through solar. That could be wise if you're looking at CO2 impacts.
Yeah, but when looking at desal, there's also the economy of scale.
Right.
To take into account. There are quite a few, particularly in the recent years with a drought, quite a few communities are considering desal as sort of that little emergency
right.
Buffer.
Well, let's talk about some communities in California. We know Santa Barbara, and if you can't discuss a point specifically, let us know. I know you're on the Water Control Board, but broadly, Santa Barbara is looking to put the Charles E. Meyer desal facility back online. That is going to happen.
Correct.
It was online very briefly in the early 90s. It's going to reactivate. In Cambria, there's a hybrid plant that's in this county. Diablo Canyon currently has desal. And some local cities and the county are looking to work with Diablo so that they can access some of that desal water. Because right now the desal in Diablo is simply for Diablo.
Correct. And the total capacity of the desal plant at Diablo is not fully utilized. So they do have excess capacity, which they certainly, through the permit process, would be able to use for other uses.
And I believe that plant is before you, so I don't want to put you in an awkward position. So I'll just mention that as I understand it, it could be a wise solution. You have a board of supervisors with Democrats, Republicans, left and right. They're 5-0 in favor. And all that really needs to be done, as I understand it, is a pipe, a 7-mile pipe, needs to leave kind of the edge of Diablo and connect up with another pipe in...
they're actually considering even extending the pipe all the way to Lopez Reservoir.
Right, it would ultimately get to Lopez Lake. So exciting indeed.
Yeah, absolutely.
But where do we go from here? Because while desal is kind of the popular technology du jour, should we be really turning to that? Because it does seem like every community, Huntington Beach is looking at it, Dana Point is looking at it, Camp Pendleton in San Diego County is looking at it. A lot of folks are looking at this.
Well, there's certainly, as you pointed out, the cost. There's also an environmental impact, which is undeniable. But what is being looked at quite significantly and encouraged by the Water Board is to look at a better use of recycled water from water treatment plants. Because if you take, as I mentioned, the rejection rate of seawater to bring it to drinking water standard, you're looking at about let's round the number 50-50. With recycled water from a water treatment plant, once it has reached tertiary level,
which is non-potable.
It is non-potable, but it has been treated.
So it can go to landscape.
Right, or exactly as an example. Well, if you take that water and you bring it to drinking water standard, then over 80 to 85% of that water can be converted to drinking water.
So you can go from human wastewater to tertiary to drinkable at an 80 to 85% save rate.
Right.
That's remarkable.
And one of the benefits, of course, is the energy cost, because it takes a lot less energy.
But how do you convince humans
that
you can drink human wastewater that's been treated?
Yes, that's the next step of mindset understanding.
I gotta think, sir, it's probably cleaner than any water you can imagine. What do I know? But.
Well, what's taking place in the new regulations is that you can take that water, and then that water is re-injected in the ground,
and then it gets cleaned again.
And then we provide a certain amount of time required before that water can pump.
He is Jean-Pierre Wolff. I'm Brad Pomerance, Charter Local Edition.